Here we go with completing the square. So completing the square we're going to be using for this unit, and in this unit we're going to be studying what's called conics. Now we're going to start off with parabolas. Now completing the square you did do in your Algebra 2 course, but it may have been a while. So let's walk through this. We're going to be working with solving a quadratic equation of the form, I apologize there. Let's go ahead and clean that up a little bit because that's a little yucky. All right, so we're looking at forms ax squared plus bx plus c equals 0. So again, a quadratic equation is an equation that is of the second degree, okay? Now, what we're going to be using this predominantly for is, rather than to solve this equation, now this is what we will be doing in this section, all right, but not in the next section. In the next section, we're going to be using completing the square to write it in a different form, okay? Now, when we do completing the square, we want the leading coefficient here to be a positive 1. All right, so our first step is going to be if it is something other than 1, we are going to need to divide that equation by that coefficient. Step 2, now I do have these printed out and I will give this to you in class on Tuesday. Right, the second step is to move the constant term over to the other side. The third step then is what I typically refer to, well, that was kind of interesting, as the aside step. Now this aside step is you're going to take the middle term, divide it by 2, and then square it. This will then give you some number, which I uncreatively call the magic number, okay? Then using the result of step 3, we're going to do the golden rule of algebra, and that is whatever you do to one side of the equation, you're going to do the other. So we're going to add then this magic number to both sides. By adding then the magic number to both sides, what that enables us to do is complete a perfect square on one side by using factoring, and then on the other side we are able to solve. To solve then, we will simply use extraction of roots. Now remember, whenever you introduce a radical to a problem, you will need a plus and or minus sign. So let's go ahead then, let's consider this example here. So in this first example, I want to look at the equation x squared minus 8x minus 15 equals 0. Now upon quick inspection, you will see that this is in fact not factorable. You might be thinking -3 and -5, but due to the fact that that last term is negative, that means they need to have different signs, so it is not factorable. So we then resort to using completing the square. If we look at that a, we see that it is already a positive 1, so therefore we do not need to do that first step and do division. We stop right then on this step 2, and that is to go ahead and add 15 then to both sides. This then gives me x squared minus 8x equals then 15. Now from there then, this is where we're going to go ahead and do the aside to create that magic number. We're going to take b, divide it by 2, and then square it. Again, this b is the same b as used in the quadratic formula, so it is the coefficient of x. So that's going to be then a -8 divided by 2, and then square it. Following order of operations, we're going to do the division on the inside first. Squaring that -4 then gives me my magic number to be 16. Now we're going to take that 16 then, and we are going to add it to both sides of that equation. Now the right hand side is easy, that's just going to be 31. If I subtract 31 then over to the other side, it ends up back being x squared minus 8x minus 15, which does us no good, okay? However, the whole purpose of creating that magic number was to complete a square, because x squared minus 8x plus 16 is now factorable. It is factorable into x minus 4 times x minus 4, or more conveniently, x minus 4 quantity squared, hence the name, completing the square. So from there then, it's nice to go ahead and solve. All we need to do is take, whoops, that was kind of yucky, take the square root of both sides, And in doing so, since we introduced a square root, we can't forget the plus or minus sign on that 31. The square and the square root are going to cancel out, so that then gives me x minus 4 equals then plus or minus 30, square root of 31. And then solving for x, we can go ahead and add 4 then over to the other side to give me then my final answer of the square root of 31. Now remember, we always want to simplify that radical as much as possible. I did post a link on Blackboard to refresh your memory on how to simplify a radical. So let's go ahead then, let's take a look then at this next one. In this one, I want to go ahead, I want to solve x squared plus 6x plus 1 equals 0. Again, first thing we checked is that it's not factorable. And in that first step, we notice that a is in fact a positive 1. So that means there is no need to divide. So moving then on to step 2, we can go ahead and subtract 1 then from both sides. This then gives me x squared plus 6x equals a negative 1. Now we're going to go ahead then and create a magic number using then the aside. And again, that formula is b over 2 quantity squared. This then gives me 6 over 2 squared, which is 3 squared, and 3 squared then is 9. So 9 then is my magic number. We're going to go ahead then add 9 to both sides. Now negative 1 plus 9 is 8. X squared plus 6x plus 9 will factor in x plus 3 quantity squared. From there then, we can not let that happen. We can undo that hideous square root. Okay, now we're good. All right. I can't figure out what I keep hitting. All right, anyway, we can go ahead then, take then the square root of both sides. This then gives me x plus 3 equals then plus or minus. Square root of 8 is going to simplify into 2 square roots of 2. And then, of course, naturally, we're going to go ahead and subtract 3 then from both sides to give me then x equals a negative 3 plus or minus 2 square roots then of 2. All right, fantastic. Let's take a look then at this one. In this one then, I have x squared plus 10x plus 13 equals 0. Again, not factorable and leading coefficient of a positive 1. So my first step is I'm going to go ahead, subtract over the 13 to the other side. In formulating then my aside, again, that's going to be b over 2, square that, which then gives me 10 over 2 squared, which becomes 5 squared, which is 25. So 25 is my magic number. So therefore, we're going to go ahead, add that to both sides. This, then gives me x plus 5 squared equals then 12. And taking then the square root of both sides, remember we are going to simplify that square root of 12 to give me then x plus 5 equals plus or minus 2 square roots of 3. Subtracting then the 5, oh that's ugly, over to the other side. This then gives me negative 5 plus or minus 2 square roots of 3. Let's erase that, that's ugly. Okay, cool. Awesome, awesome. Okay, I'm not going to do that one. Let's take a look though at this one. One more just for good measure that's nice like this. So again, not factorable. A is equal to 1. First step, move that constant term over to the other side. Working then on the other side, that's going to be b over 2. We're going to square that. So this then becomes a negative 22 over 2 squared, which is a negative 11 squared, which gives me then a magic number of 121. Of course, we're going to go ahead, add that then to both sides. Now 19 plus 121 is 140. This side then will go ahead and factor into x minus 11 times x minus 11, or more conveniently, x minus 11 squared. Introducing that square root, we don't want to forget that plus or minus sign. Now 140 will break apart in its 4 times 35, which becomes then plus or minus 2 square roots of 35. And then, of course, we're going to go ahead, add that 11 over to the other side. This then gives me x equals 11 plus or minus 2 square roots of 35. Fantastic. Absolutely fantastic. Okay. Cool. All right, I got plenty of space. Sorry, just checking my bounds here. Now, let's go ahead. Quadratic equations, all right, or quadratic equations can be solved no matter what using completing a square. So if I have something like x squared plus 7x minus 13 equals 0, obviously this is not going to be factorable. We have a equal to 1, so that's all fine and dandy. So we can go ahead then add that 13 to the other side. Now, just like before, we're going to go ahead and create that magic number. The formula is the same. However, this time, the middle term is odd, which means it's not evenly divisible by 2. But that's no problem at all. When we go to square it, we're just going to go ahead and square top and bottom. So instead of getting a nice whole number as our magic number, we are going to get a fraction that is our magic number. Like before, we are going to go ahead and add that then to both sides. Now, to add fractions, as you recall, we need a common denominator. So that 13 can become 13 over 1. Building that up then so that it has, in fact, a denominator of 4 to match that 49. 13 times 4, all right, it's too late on Friday night for me to be thinking about that, is 52. So this is going to be then 52 over 4 plus 49 over 4. 52 then plus 49 is 101, so that'll be 101 over 4. Okay. Now, as we take then a look at this, that left-hand side looks like a mess to go ahead and try to factor. However, let's see if we can use something from our past to help us factor that. Well, if you look at this last example, we notice that the b over 2, when I took a look at it, was a negative 11, and it factored into x minus 11. In the one prior to that, my aside, my b over 2 is 5, and it factored into x plus 5. In the one before that, my b over 2 was 3, and it factored into x plus 3. And even in the very first one, my b over 2 was a negative 4, and it factored into a negative 4. So whatever my b over 2 was ended up being my middle term. So when I go then to factor this crazy looking equation, x squared plus 7x plus 49 over 4, my second term I factor is going to be my b over 2. So in that case, that's going to be then 7 halves. So factoring this down then, this will be then x plus 7 halves squared equals then 101 over 4. Now if you want to go ahead and multiply that out using FOIL, you'll see then that you do get that original expression. Now from there, it's the same deal. We're going to go ahead and take the square root of both sides. This then gives me x plus 7 halves equals then plus or minus. Now the square root of a fraction, you're going to give it to the top and to the bottom. All right, and then solving for x gives me x then equals a negative 7 halves plus or minus then the square root of 101 over the 2. Fantastic, fantastic. Okay, let's try another one that is similar but looks a whole lot more scary. If I have x squared plus 2/3 x minus 1/6 equals 0. In looking at this then, again, leading coefficient is a positive 1, so that's a good thing. All right, so we're going to begin as normal by adding that constant term over to the other side. And then like before, we're going to go ahead and do our aside. Now our aside is going to be b over 2 squared like normal. Well, our b in this case is a fraction. It is 2/3. We're going to take that 2/3 divided by 2 and then square it. Well, let's think about this for a second. Okay, get a nice big thought bubble going on here. 2/3 over 2. Well, 2/3 divided by 2 is the same thing as 2/3 times 1/2, which is 1/3. So that inside is really just 1/3. Okay, so this is then 1/3 squared, which is then a 1/9. So that looks good. So we're going to go ahead. We are going to add then that 1/9 to both sides of the equation. Now, like we did in the last example, since we have that factoring, this is going to factor then into x plus whatever my b over 2 was. So my b over 2 then was 1/3. And again, if you want to try that out, multiply that out using FOIL. And then on my right-hand side, I need to build those up with a denominator of 18. So that's going to be then 3 over 18 plus 2 over 18, which is then 5 over 18. Of course, then we're going to go ahead and take the square root of both sides. Now remember, when you take the square root of a fraction, it is square root top, square root bottom. Remember, we need to go ahead, we need to simplify that denominator. 18 will be 9 and 2, which is then 3 square roots of 2. And we can't leave a radical in the denominator, so we need to multiply then top and bottom by the square root of 2. That is rationalizing. So I have then x plus 1/3 equals then plus or minus the square root of 10 over 6. And then, of course, subtracting the 1/3 over to the other side. So it's a negative 1/3 plus or minus then the square root of 10 over 6. Now, in all of these examples, life has been fantastic because that a has been a positive 1. Let's take a look at an example in which that leading coefficient is not a positive 1. So 3x squared plus x minus then 1/4 equals 0. Like usual, my first step is going to be to take that leading coefficient and check to see if it's 1. Since it's not, we're going to go ahead, we're going to divide then both sides by 3. Now that 3 is going to go into each and every single term. Because again, remember, a polynomial divided by a monomial, it's got to go into everything. So an equivalent equation then is x squared plus 1/3 x minus then 1/12. Now that that leading coefficient is a positive 1, we're going to take that constant term and move it then over to the other side. And then begin the process of doing my aside. Now again, that's going to be b over 2. We're going to square it. This then becomes 1/3 divided by 2 squared. And think about it, 1/3 divided by 2 is the same thing as 1/3 times 1/2, which is 1/6. So this is then really 1/6 squared, which is then 1 over 36, and that's going to be then my magic number. Adding that then to both sides, now 1/12 plus 1 over 36, we need a common denominator. 1/12 is equal to 3 over 36. 3 over 36 plus 1 over 36 is 4 over 36, which reduces then down to 1/9. Sorry, I got a little carried away there. Let me rewrite that. Okay. All right, there we go. All right, so that side will be, sorry about that, touchy, literally. Okay, anyway. This will then go ahead and factor, just like before. Remember, that's going to be our b over 2, so this is going to factor then into x plus 1/6 squared. Again then, craziness happens. We go back here. Okay, we're good. Take then the square root of both sides. This then gives me x plus 1/6 equals then plus or minus. Now this one's nice because both the top and the bottom are perfect squares. Since they are then both perfect squares, that means that we can go ahead and split the problem up and get exact values then for x. So x is then equal to 1/6 minus 1/3, which is 1/6 minus 2/6, which is a negative 1/6. And then over here, x is then equal to a negative 1/6 minus 1/3, which is a negative 1/6 minus 2/6, which is a negative 3/6, which is then a negative 1/2. And then there's my two solutions for that particular instance. And one more like this, just to make sure everything is all hunky-dory. So let's take a look then. I want to look at 2x squared minus 3x minus 1 equals 0. Again, first thing I notice is that I need to make that a 1, so I'm going to go ahead and divide then both sides by 2. This then gives me x squared minus 3/2 x minus then 1/2 equals 0. Again, remember, it needs to go into every term. Again, I apologize here. That's pretty. Okay, let's go ahead. Let's erase that. Okay. Now, taking it from there, we want to add that constant term over to the other side. Creating then our side. Again, it's going to be b over 2, and we're going to square that. So this then gives me a negative 1/2 squared divided by 2 squared, which will be then, I wish I knew what I was hitting that did that. I am so sorry. All right, so this becomes then a negative 3/4 squared, which is then positive 9/16. Okay. So adding that then to both sides, it's going to be then x squared minus 3/2 x plus then 9/16 equals then 1/2 plus 9/16. Now 1/2 plus 9/16 is the same thing as 8/16 plus 9/16, which is then 17/16. And of course, factoring then the left-hand side, remember that's going to be our b over 2 term, okay? And then of course, taking the square root of both sides. Now, fortunately for us, the bottom here is a perfect square, okay? So this will then go ahead and be x minus 3/4 equals then plus or minus the square root of 17/4. And then adding that 3/4 over, we solve for x. All right. So that is how you solve completing the square in your Algebra 2 class. Now, at the beginning of this lecture, I did say that we are going to be using this, but not quite in this capacity as in solving for x, but rather writing this equation in a different form. So when I take a look then at this equation, so f of x equals then x squared plus 14x minus 5. These are the two examples then from section 3.3. As you look at this, rather than the equation being equal to 0, it's equal to f of x. Well, we're going to treat it exactly the same way. The first thing we need is for this to not happen again. I'm so sorry. Let's erase that. Okay. So we need that a then to be a positive 1, which in this instance it is. So that is fantastic. Okay. What we're going to do then from there is, just like before, we're going to add that constant term over to the side where it is equal to 0. So in other words, we're getting that x squared and that x by itself on that side. Just like before, we're going to go ahead, we're going to create the aside. It's going to be b over 2, and we're going to square it. So again, that's going to be then 14 over 2 squared, which is 7 squared, which is then 49. We're going to go ahead then, erase that because that's ugly. Okay. Add then the 49 to both sides. So f of x then plus 5 plus then my magic number of 49, x squared plus 14x plus 49 then on the right hand side. As we then look at this, the x squared plus 7x or 14x plus 49, that is in fact going to be factorable. That'll then go ahead and factor into x plus 7 squared. And then on the left-hand side, that's just f of x plus 54. Now, rewriting this, I'm going to go ahead and subtract 54 over to the other side. Erase that off the line. This then gives me that f of x then equals, that's ugly. Okay, clean it up a bit. That then equals x squared plus, what did I write? Okay, sorry, back it up. Okay. This then gives me f of x plus 54 equals then x squared plus 14x plus 49. Writing it then equal just to f of x. Oh, sorry, I'm getting ahead of myself. It is midnight and I need to go to bed. Okay, so f of x then plus 54, factoring the right-hand side, x squared plus 7. Yeah, that. Now, solving then for f of x, we're just going to subtract that 54 from both sides. So x plus 7 squared minus then 54, okay? So we kind of used completing the square there. We just simply rewrote the equation. Notice we didn't use step 6 where we took the square root of both sides. We just rewrote that equation a little bit. So now let's go ahead then. I want to do another example. Now this one is a little bit weird. This is f of x equals 2x squared minus 20x plus 20. So again, as you look at this, the first thing you notice is that this equation is also not factorable, okay? So since it's not factorable, all right, we're also not solving for anything because it's equal to f of x rather than being equal to 0. So I'm going to start like how I did in the last problem. We're going to look at that coefficient of x squared. It is currently a 2, but remember we want it to be a 1. So we're going to alter this ever so slightly. When we typically do completing the square, we would divide both sides of the equation by 2. Well, we're not dividing in this instance because we can't divide f of x. It's not a number. So rather than doing the division, we're going to factor out a 2 just from the first 2 terms of the expression. So in other words, just the 2x squared 20x. We're not going to touch the 20 at the end there. All right, so it's going to chill out there on the other side. Now that that x squared is a positive 1 as a coefficient, just like we did for completing the square, we're going to move that 20 over to the other side. So now it is starting to kind of sort of resemble completing the square. Now we want to go ahead. We are going to do completing the square for just that inside portion of the graph, okay? So for just the x squared minus 10x, we're going to create then the side just like we did before. So that's going to be then b over 2, and we're going to square it. This then gives me a negative 10 over 2 squared, which will be then a negative 5 squared, which is 25. So 25 then is going to be my magic number. Now, here's where it gets to be a little bit hairy. It is for what is on the inside of those parentheses. So we're really looking then at it being x squared minus 10x plus 25. That's going to make then this polynomial factorable into x plus 5 quantity squared, okay? But we need to be careful because we're not adding just 25 to the equation, but rather 25 times 2. So in other words, we're really adding 50 to both sides. So that's going to be then f of x minus 20 plus then the 50. So that's going to be then the magic number, okay? So then that becomes, I'm so sorry. Okay. So this then becomes f of x plus 30 equals then 2 times x plus 5 squared, which is then, good Lord, it's the last example, so it's going to be the biggest pain. Okay. So subtracting then the 30 from both sides, this then gives me f of x equals 2 times x plus 5 squared minus then 30. Again, we haven't solved for anything. We just rewrote this equation. All right, so you need to go ahead then. You can work then on section A6. If you have questions, feel free to go ahead and email me, or we'll talk about it on Tuesday. Other than that, guys, please take a look now at section 3.3 video.